Assalamualaikum and a very good evening to Medium Cenduri. My name is Muhammad Aiman and I will present to you about control and uncontrolled half wave rectifier. So for the first circuit, as you can see, we use a half wave resistive. So to make a circuit for the component, we use a signal component and then a diode, one diode, and then a resistor, and then the last one is ground. So as you can see, so for the resistor, we use as a component that will cut off the remaining current, so that it will not have a trouble, so will not have a problem for the circuit, and it will not overload. So for the diode, we also known as a forward bias. And that's why it known as a positive cycle. So for the waveform, as you can see, for the output waveform, as you can see, at the bottom, it cut off a little bit from 0 to negative 2 volt. It is because of resistor that cut off a remaining current. So that is for the first circuit. Okay, so for the second circuit, also known as half-wave rectifier inductive load, as you can see at the circuit, we add one inductive that beside the resistor. The inductive load, known as a component that restore the amount of energy that so big, so that it will not have a troubleshoot at the circuit. So as you can see at the output waveform, you can see at the bottom of the output waveform, you can see there is a tiny waveform. There is because of a current discharge from the inductive load, and when you store energy in inductive load, it will discharge the current a bit by bit. So that's why you can see that the current not fully cycle because of a inductive load that keep discharge a current bit by bit. So that is for a circuit half-wave rectifier inductive load. Okay, so for the third circuit, also known as half-wave resistive inductive with freewheeling, as you can see, we have one more diode that we use as a freewheeling. So the circuit has a positive cycle, but when the current flow through the freewheeling diode, it will change from positive cycle to negative cycle. And the current will keep running through the circle and will not run out because of freewheeling diode. So as you can see from the output waveform, it also known that as from the output waveform, you can see that it has a little bit small waveform from the bottom because of a inductive load that keeps storing energy, and it will keep discharge a bit by bit. That's why we can see a small tiny waveform from the bottom. So that's it about a half-wave resistive inductive with freewheeling. Discussion for the first question is a compare the peak voltage between input and output for resistive load. So the voltage dip that occur across the diode are the reason why the peak voltage is lower than the peak input voltage. So for the second one is explain the effective of inductive load. So the circuit will have been powered by voltage supply for a positive cycle due to the impact of an inductive load. Inductor charge occur as a result of the supply voltage and the diode's forward bias. Reverse bias caused by the diode to open circuit later on in the negative cycle. So the diode was changed into a forward bias reverse diode once the inductive became a circuit supply. So the diode become reverse bias back and turn into a open circuit with no supply up until the time at which the inductor fully discharged. As it resumes the positive cycle, the waveform repeats. So for the third one, explain the effect of freewheeling diode for inductive load. The circle positive cycle was identical to that of a freewheeling diode now in use. However, it is moved into a negative cycle. The inductor will only feed the resistor and freewheeling diode. The discharge rates of the inductor stay lower than before since it just supply power for the resistor. The circuit enter positive cycle once more before the inductor completely discharged. As a result, the circuit receive constant current and the voltage output has only positive cycle. And for the fourth one, compare between practical and theoretical result. So there is a little different lah in a input voltage value between the practical and theoretical result. The diode voltage is to blame for this. The graph for the freewheeling diode circuit was somehow incorrect. According to the theoretical result, the graph should only contain positive cycle only, but instead it had higher voltage average. So yeah, so for the fifth one, conclude your finding. So the graph can be put into 3 uncontrolled wave rectifier. According to my research, the first circuit give us a guidance on how to determine the voltage for the resistive load. So the value is an effect by the voltage supply, the input voltage for each circuit was the same. The resistor and the inductor base current that used in an inductive load. Inductive charging for positive cycle and forward bias diode. Due to reverse bias when it enter the negative cycle and the inductor supplying the circuit current, the diode opened up and become forward bias back it reach as the negative cycle. Yeah. So that is my conclude for this finding lab. So I hope you understand my explanation. Thank you.